Ouais, mais c'est pas grave. T'inquiète, merci. Il est allumé du coup?
Ouais, il est allumé.
Nickel.
Et tu peux le mettre en pause.
Ok, cool. Et là, l'HDI. Et pas de Ok, cool. Euh, on GitHub, on my GitHub, my personal GitHub. Yeah, I'm just finishing the thing. Okay, everyone, we can start if you're all ready. Yeah, it's all good? Okay, cool. So today we will be creating your first smart contract in Cairo. So I've already made the smart contract. I will show you how it looks like. So it's something like that. This is a smart, no, not this one. This is a smart contract. And there is a bunch of components in the code, and you will have to create everything. And what your smart contract will do, it will be something to play a game, like some game theory. So I've also made a small website like that. So you just connect to a board, which is another smart contract actually. Yeah. Okay. Like this board, you connect to it, and there is a bunch of players on it, and players can just like fight, steal, do nothing, some bunch of stuff. And there is multiple rounds, and so you will all have to create your own player. So each player is a smart contract, and what you will have to do today is to create a player, so at the end of the workshop, we can all play together and yeah, try to be the winner. So what is the purpose of the game? It's just some game theory. So at the beginning of the game, I distribute 100 points to everyone, and after each turn, you all receive 10 more points, and you can decide to give some points to someone else or to steal, and you can decide what do you want to do when you get stolen or when you receive something. Do you want to split? Do you want to say to everyone, this person give me something? Or do you want to say to everyone, this person steal me something? Or do you want to fight? So you will lose even more, but the person who steal from you will lose even more also. Or to steal back. You can do some stuff. So we need a smart contract to do everything. And for the moment, we only have, I think I can zoom on that also, yeah. We only have the board, which is this smart contract that I've coded, and you don't have to do it, but you will have to do this one, which is the player. So you can start by cloning this repository, this one. So it's on my personal account. It's this. So as you can see on the main branch, everything is already here, but you will have to check out another branch, which is W for workshop, 42 blockchain /1, because maybe we will do even more workshops. It's good for everyone? Okay. So this is what we have on VS Code. I let everyone open the repository and open VS Code. It's good for everyone? No, okay. Yes, the branch W/42 blockchain /1. I guess everyone know how to check out the branch. Yeah. So I'll just show you how to do it. So you can just go to a random folder, type git clone. And then you go into Starknet workshop layer, then git checkout W/42 blockchain /1. And it's done. Okay, good for everyone? Okay, so it's supposed to be split in multiple steps. Sorry. Okay, so the steps are here. I don't know if I can zoom on it. Yeah. Okay, cool. Okay, so the first one will be the structure. So we won't write much code for the first step, but we'll just have our structure with like all our components and utilities. So what do we need is a smart contract. In Cairo, a smart contract includes components. So we will have to create a folder for our components here. Components. And another one for our contracts. Actually, we'll have only one contract, but on some projects you can have multiples, so just write contracts with an S. Then we will have a player contract, so you can create a folder, player, inside contract. It's hard to talk on the mic and code at the same time. Then you can create a player.cairo file here, and this will be the contract. But to link stuff in Cairo, like everything starts from a lib.cairo. But if we want player.cairo to be compiled as well, we have to tell Cairo to look into a contract folder. So we need to add, not a folder, to add a file which will be contracts.cairo. Yeah. When you create a folder, you need to have a file name with the same name. I think this will change in the future because that's quite verbose and a bit useless, but for the moment you have to do it. So same here, we have player folder, we need the player.cairo. And inside lib, we can remove everything. We need to specify that we want to include contract, the file contract. So pub mod, pub for publish, mod, like in Rust. Contract. Everybody is following so far? No? Do you want me to show a previous step? Okay. Like here you have your sources here. Inside there is two folders, components and contracts. You can ignore components for the moment, just contracts. So you have a lib, which is kind of the entry point of your sources, like index.js or main.c. And then from lib you include contracts.cairo. There is nothing in it, but the way to include it is pub mod contracts. And in contracts, you can include player, which is in the contracts folder. So in contracts here, you will make pub mod player. And in player here, you will do the same thing. So from contracts, we are including player, which is here. So from player, we will include player, which is here. So again, pub mod player. And inside this, we will create our contract. It's good for everyone? No. What are you missing? No, pub mod player. So having contracts.cairo here with the contracts folder is like having lib.cairo inside contracts folder. I don't know if that makes sense. That's just a weird logic that you have to get familiar with. It's only in Cairo, but yeah, I know it's weird. We can go into the next steps if you're ready. Okay, so after creating that, we create the structure for our contract. So we'll have to type that hashtag Starknet contract. And then mode and the name of our contract, which will be player. So this is a contract. As you can see, Scarb is throwing me an error here, which is that contract must define a storage struct. So we can add it by doing storage struct. And this way, okay, this way it should work. Yes. And now this compile. This can compile. So we have an empty smart contract that we can actually compile if you want to test. Like here, if I run scarb, I just run scarb clean to make sure. So scarb build. Yep, it's working. I'm building nothing, but it's building. So now we will have to add components. Does everyone have this working? Yep. Okay, so I will be adding components. So components. And again, I will have to create components.cairo and component folder. And inside component, our player will be able to do 3 things. So the first one will be to register to a board, to register to a game. It will also be possible to steal or to give something to someone after each round, and also to define strategies to react when you get stolen or when you receive something. So we can split these 3 kind of actions into 3 components. So we have the reactor, the behavior, and the participant. So participant to register, behavior to steal or give, and reactor to define strategies when you get stolen or receive something. So again, we have 3 folders, so we have to create 3 new files, which will be reactor.cairo. Once you have this structure defined, I know it's a pain at the beginning to do it, but once it's defined, it's cool. You can just start coding. Participant.cairo and behavior.cairo. Yep, and each component will have to define some interface to be able to interact with it, and some code. So we can split this into 2 files. I will just put the mic, and you can see what I will do. So we can split this into 2 files. I will just put the mic, and you can see what I will do. So for each component, we will create a behavior.cairo for behavior and interface.cairo. So the code of the component will be in behavior.cairo, and the interface to interact with it will be in interface.cairo. We can do the same for participant and reactor. So now we'll have to go back to the beginning, to the root of our sources here, and start including everything to make sure that every file is detected by the compiler. So first we start in lib, and we have to include pubmod components. Then from components, we'll need pub mod reactor. Then behavior and participant. And again, inside behavior, participant, and reactor, we will have to do the same. So behavior will include behavior also here and interface. Pub mod behavior and pub mod interface. Yep. Not yet, but I will. It's already created here. Like when they've cloned the repository, they have a toml file. But we will add dependencies and everything into the next steps. So I will just do the same for participant. Participant and reactor. Here? Now here is where I will put the logic, the interface in and the logic of the component. So in Cairo, most of the time, you will only have code and logic or interfaces inside, like at the bottom of your file system. Like every file between the root and the bottom of your file system, it will just be files to include the next files. Like this is just to include stuff. Same here. You can put logic inside, but it's not a common practice and not a good design pattern. Yeah, I will just see with everyone if it's all right before continuing. just to make sure that you can compile. I don't know why it's working on my side, but you have to add this here. Starknet equal, which makes a good transition to the scarp.toml, which is the config file of your project. So here you can add dependencies, and we will need two dependencies in our project. The first one will be OpenZeppelin. So OpenZeppelin is it's a bunch of helpers and smart contracts. And to add a dependency, the best way to do it for the moment with Scarb, you can do Scarb add like with any other package manager, but it's not always working fine. So a good way to do it is just to do it like that. I will just copy the line and explain you. So we tell Scarb to add the dependency at this address. So it's a GitHub repository, the branch, which is main, and the name of our package. So I will just zoom out a little bit. Okay. So you can just add this. Here we're adding Starknet also to have access to Starknet.contracts, to storage, which are stuff related to Starknet, but not to Cairo specifically. So we need Starknet, OpenZeppelin, and we will need one more dependency, which is board, and which is like from this repository. So you can just copy this, put it here. So this way you will have access to the code of the board which that your player will connect to. So we'll have access to some interfaces and structures and yeah, a bunch of types. Like in the board, you define the I've defined the strategies, like when you lose or when you receive something. And you can use these strategies, this strategy type, inside your project here without having to redefine it. So you include OpenZeppelin and board. And also, when you make any modification to your dependencies, you can refresh them doing scarb update. Sometimes it's needed because Scarb does not always detect that you've made some modification. So Scarb update. Or let's say you're working on OpenZeppelin and you're using it inside your project, but you want Scarb to, like you made some modification to OpenZeppelin and you want Scarb to refetch this modification. Also Scarb update and yeah, as you can see, updating Git repository, the board and the OpenZeppelin Cairo contract. Also, in your scarp.toml, you can define compilation-related stuff. So here we're creating a smart contract. So we want we will tell Scarb that we're creating a smart contract. So we will add these things like target, smart contract, Sierra, and Kazem. So it's two formats of smart contract. I think that if you've been there during the last 3 days, you may remember this. That's not the point of today's session, so I won't go into the details. Let's say by adding that, if you compile again, I can do scarb update. It should be working, and it should. Yeah. And you can find your compiled smart contract here. So I have player.sierra.json. Oh, sorry. I compiled without saving my file, so this has been ignored. I will just do scar build again. And here you will see the smart contract being created. Yes. I can switch to another screen. No, just yeah, feel free to take a photo. Okay. I may have forgotten something. No, that's good. Okay. And so here you can see this is your compiled smart contract. It's quite empty because our smart contract is empty. It's not doing anything. So yeah, the compiled version is not doing much things yet, neither. Like, so for the next step, we can start creating our components, like or at least the structure and the interfaces. So we'll have to use that kind of thing again, Starknet contract, but we need in interfaces, Starknet interfaces. Not this, Starknet interface. And we will define, if you're familiar with Rust, it will be the same, something that you've already seen. So pub trait. So we call our interface eBehavior, iBehavior, I for interface. And this interface will use a generic parameter, which is the state of your component or your contract or whatever you're using. So this is an empty interface. And you can put it here also, and here as well. We just have to rename it then. Participant. Yep. Because the contract, okay, so you have three main states, contract, component, and interface. I think I can have a good explanation on my GitHub here. Okay, so on Starknet, yeah, I should have started with this. So on Starknet, when you want to create an application to deploy a smart contract, you can think like that. So this is Starknet. This is the state of Starknet. And you can see Starknet as a world computer, like a computer on, like you can connect to that computer and do a bunch of stuff. And it's a shared computer for everyone all over the world. And on this computer, you can deploy applications, and you can also interact with applications. And what we're doing here is, like, we're creating an application, and we will try to use it after. So first, we are creating this. So this is a class, and the class holds a bytecode, like that. This is the compiled version of our smart contract. And what we're doing now is we are creating this bytecode, and then we will declare this bytecode onto Starknet. And once this bytecode will be on Starknet, we'll be able to deploy contracts, which is like an instance of a class. I don't know if you're familiar with object-oriented programming, like in CPP or many other languages. Not like in C. But it's like creating a class, and this is an instance of a class. So if you want to interact with your code, you will have to create an instance of it. So yeah, for the moment, we're just creating the code to create the class, and then after we'll create a contract to interact with this class. And inside the bytecode, at the root, there is a smart contract. And the smart contract is implementing components. Inside the components, so you have some code, and this code is defined following an interface, and this interface is defined in this Starknet interface. So what we're doing now, here, is creating the interface. So we're creating this part. Then the implementation, so the code related to this interface, will be in participant or behavior or reactor here, inside a Starknet component, and then we will aggregate these components inside a Starknet contract. Makes more sense? Yeah, yeah, that's something else. No, it means that it's a generic type, but what you're referring to, I guess it's if you're doing something here, like let's say I want to define a function, if we call test, and then we have this. Okay, so inside the when you create a mod, I don't know if we can say that, and you add this directive, so Starknet contract, the compiler will automatically create inside a contract state. And the contract state is an object that you can use to interact with the storage, with the events, and with everything inside your contract. Yeah, and that's what we pass here to the interface, here the T state. So we will define an interface, and we will give to this interface the contract state here, which is T state, but it can change from a contract to another. So we need to use the generic parameter here and not directly define type. Because like if I want to put this function inside my interface, like for the interface, contract states means nothing. So we have to put T state. I can remove that. Okay, so does everyone have the interface ready? Yeah, this one. It was just for an example. I removed the test function. It was just to explain something. Sorry. Okay, so if you have your interface is ready, I behavior, I participant, and I reactor. We can start creating the contract, the component. So it will be again a new directive, Starknet, and now component. And we can just copy past that. I just forgot to put pub here. So we can just copy paste that here, because it will be the same structure. And now we have a component, which I should rename to behavior. I can put the same, sorry. Okay, and just to specify that it's a component, it will be easier than to manage the code. We add component at the end. Yep, that's it. And then we can compile that. I will go back to the example. It's compiling. So again, what we are creating is that, a component. So we will have a participant, reactor, and behavior. And each of these components will implement some logic defined by interfaces. And then we will aggregate everything inside the smart contract. Then we will compile the smart contract into some bytecode. And then we will declare this bytecode onto the blockchain. Then create an instance of that bytecode, which will be a contract. And then we can interact with our contract from a website or whatever you want. This is a quite long journey from the interface to the contract, but it's cool. Okay, so everyone is ready to go to the next steps? Okay, if you're actually ready to start implementing, no. Is everyone ready? Okay, cool. You can just type this command and it will update your repository to have exactly what I have on my computer. So if you just made a mistake or anything, it will be reset. Just if you're a Git beginner, we're just like fetching the new commit I've created and just like reset and cancel any other local change you had to just yeah, go back on this one. Actually, no, I've had it this origin. Yeah, sorry. Just do this one again instead. So, I can zoom a bit more if you need. It's all good? Okay. So now we can start creating. We just like completed one step. So well played. We just have a few more steps. So we can create our interfaces. And we won't add logic yet, but just like define the interface for our logic. So what do we want for the behavior? So we need our player to be able to steal or to give. So we need two methods, one to steal and another one to give. So as you've seen yesterday, to create a method, a function, it's the word fn for function, like in Rust. The name of the function, so we can start by give, and the parameters. And here, we'll just have, like any method for a smart contract in Cairo, the first parameter is the contract state. An object which is called self to have access to your storage, to your events, and yeah, to have access to the core logic of your smart contract and other methods inside your smart contract. And there is two ways to give the contract state to a method. Either we do it like that, self, and we pass this. And this way, if you're familiar with Rust, you know that self is not modifiable, that you cannot mutate self. So that is for methods that won't update the state of the blockchain. But if you want to modify the state of the blockchain, you will need to pass this. Ref self t state. And give, to give something, we'll have to modify the state of the blockchain to say that we want to give something to someone. Like we need to save this action into the blockchain, so we need this, ref self t state, because we will modify the state of the blockchain. So we have at the first parameter the contract state, and we also need a recipient for our donation, so we can use a name. And the name, it will be just felt 252. Yep. And the function is not returning anything. If you want to have a return type, it will be like this, so like just a random type. But it's not returning anything. We're just like giving something. We do not expect any output on this function. Why a felt here? Because a felt is just a quite big number, as you've seen yesterday, and we can store 31 ASCII characters in it, so it's more than enough for just a name. We can just copy-paste that and have the same logic for steal. So now we have an interface which define we have some actions, giving and stealing to someone with a name. Make sense for everyone? Okay, cool. So now inside, do you want me to keep that on the screen? Okay. All good? Okay, so we'll do the same thing in participant interface. So we want a method to be able to register to a board. So register. Again, to register, we have to save something on the blockchain. We want to save that we are registered to, we've registered to a game, to a board. So ref self t state. We want the address of the board, because the board is a smart contract itself, so it has an address. So board address will be the name of the next parameter, and it will have the type contract address, which we can import. It's not a native type. It's from the Cairo core library. So we have to make use Starknet contract address. This way we import the type contract address, and we can use it here. And we want to register with a name, like we want our player to be able to switch names between different games. So we have to specify also the name we will have for this game. Okay, I think that's all we need. If you want to add more features, we can also like add something to unregister. If you want to like cancel our participation in a game, you can imagine any other features, and you can add these features here. But for the moment, we just need like to register. Good for everybody? Okay. And then the reactor here. Okay, so this is a bit more tricky. This time it will be the board. Like every time someone steal or give something to you, the board will call this some methods on your player to know how to react. Like, do you want to fight, to steal back, to expose that someone steals something from you? And so it will just like ask something to your smart contract, but it won't modify anything inside the state of the smart contract. So it will just be, we call that a view method and not an external method. Just something to view what is the state of your smart contract. So receive is a method that the board can call when you receive something, just to know how do you want to react. And this time we won't pass ref self because we don't need to modify the state, just self at t state. But the board needs that you return something, so this time this function will have an output, and it will be the strategy you want to use when you receive something. And there is also already a bunch of defined strategies here. And we have, so it's an enum, like you've seen yesterday. So you have, when you receive something, you can do nothing, split, or expose. And you can either just copy that and paste it here, but it's a bad pattern. You should not duplicate code. So what we will do instead is just to import from this repository inside this one. And we already tell Scarp that we want to use board in this line. So we can just, it's called board. So we can just use board. It's inside, so lib, then strategies, then receiving strategies. So use board, strategies, and receiving strategy. And we have to import also the losing strategies, like what do we want to do when you lose something. So we can import both with brackets like that. So when you receive something, you return a receiving strategy. And when you lose something, you return a losing strategy. And again, these two methods does not modify the state of the blockchain, so we don't need to have self-mutable. Make sense for everyone? I prepared something much too complex, but okay, so now we have our 3 interfaces. And I don't think we need anything more, just to make sure that this compile. Yeah, perfect. Does it compile for everybody? No? Yes? Yep. This one? Yep. Okay, if it's good, I can just save that, and you can fetch it. Okay, so interfaces, like. Again, you can run git fetch -p git reset hard origin w42 blockchain 1. It's useless for me to run it, but and we can go to the next step, which will be the component structure. So we won't have enough time to, to do every steps. At first, I was planning to do like 5 minutes per steps, but yeah. I was planning to that we could have enough time to play the game. I've even designed some characters. Too bad. Maybe for our next workshop, if you want to come back, we can continue. And you can also do this at home. I will add a README, so we have you will have all the instructions for you to continue alone. So component structures. We can start with an easy component to start adding some logic, and then I can show you how to deploy the final contract, how to declare, and how to interact with it. And then Robert will just wrap up the session. So an easy component will be we'll just take a look at the actual code of the finalized component. This one is cool. Yeah, maybe the participant. I forgot to add something to the participant. A cool feature would be to be able to know in which board you're actually registered. So you can just add board self. Again, it's just a method to read something on the blockchain and not to update anything, just to retrieve information. So don't need to have the state mutable. And it will return a board address. Like. And I think we can, we can create the code for the participant. Okay, so first we have to include our interface inside the code of the component. To do it, we can just use. The name of our project is player. So use player. Then components. Then participant. So we are actually currently in this file. And from this file, we can include interface. And inside interface, we have access to iParticipant. Okay, cool. I just had a bunch of comments. So we have the storage here. And we will have the iParticipant implementation. So what we will be doing here is to create this step inside the component. Good for everybody? Okay. So if you're familiar with Rust, again, you know that when you have a trait, you can create an implementation of that trait this way. So implement participant. I will explain what I'm typing. It's just that it's hard to type and hold the mic at the same time. Okay, I'm always forgetting something. No, okay, it's good. So, yeah, it's very verbose. But what we did here, we created an implementation of the interface iParticipant. And here, iParticipant is taking a type as a generic. So instead of tstate, we'll have component state, which will include another generic, which will be tContract state, and tContract state will be the final contract state of the contract in which we will aggregate all our components. Maybe it's a bit complicated, but if you don't understand that, it's not a problem. You can just start creating your logic. So here the compiler is telling me that not all traits items are implemented, missing register and board. That's because I'm supposed to have register and board. I can start with the simplest one, which will be board. So just copy paste that. And here I will add the logic. And instead of having tstate, I will have this component state, tContract state. Here, contract address is unknown because I did not import it from Starknet. And voila. I can then return the board address, the current board address. So the board address will be included inside the storage. So here, it's just a struct, so I just have to tell the name of my variable and its type. So contract address. Up. And to have access to this storage, I can just use self .board .read. And as you can see, I cannot write. If I want to write, there is no auto-completion because I don't have access to, I cannot mutate the state of the storage. I can just read it. If I press an R, it will suggest read. Maybe. Yeah, read. Okay, and this way I'm just returning. If I remove the semicolon at the end, it just like return the value. Like this is the same, like in Rust again. But it's shorter to do it like that. And if I put a semicolon, it will throw an error because I'm not returning anything. So this way I can get the current board. And now we need register. Again, I will just copy paste that. And replace tstate by component state, tContract state. It starts to be a bit too wide. Okay. So here I need to add the logic to register to a board. So to do it, I will first have to save the board address. So this time I will have access to write. If I press a W write, because it's a mutable, I have access to a mutable state. And I can put the board address. That's pretty much it on the side of our storage. But now I have to send my name to the board. So I can just take a look at the board, at the interface of the board. And I can see that to register, I have just to pass a name. So I have to call the board smart contract, to call register on it, and to give my name. So how to do it? To call a specific method on the contract address, I need to have access to its interface. So this iBoard, or board ABI, I've just duplicated it. Board ABI would be better. ABI means application binary interface, and it's an interface between your binary, like the binary code you have here, which is like not comprehensible for human, and an application which is like what you're creating or a website or anything else. So it's a way for you to call a method inside some binary code, which is here. So for the moment, I just have access to an address, the address of the board, and I need to call something inside this bunch of bytecode. So I need this that I can import from board. So I can do it like that. Use board. It's inside. So board player. No, board contract interface. And board ABI. So this is the interface, but to interact with the interface, the compiler created another structure, which is a dispatcher, and I need to import also the dispatcher trait. I don't have much time left, so I cannot explain why you need the dispatcher and the trait, but you need both. Okay. So I can just do that. I give my contract address, is the board address, to the dispatcher. And this way, I can have access to methods from board. And I can do board.register and give my name. Ta-da. You can remove that. It's just that, as you can see here, the parameters have names. So you can just like send name directly, or you can send name _name. And if you want to avoid, it's just a sugar syntax. If you want to avoid having name _name, it's cleaner this way. And that's it. This way, when I call register, it takes my address, it put it in the dispatcher, so I can have access to the code inside this address. And I'm calling register on this code, on this bytecode, using this application binary interface. Then this code will be executed. Register, no, not here. This method from the board will be executed. As you can see, there's some logic, not too much, but it's just making some assertion just to make sure that the name is not empty, the game is not already started, you're not already registered, some stuff like that. And then you save that you're playing with this board. And to save this, it will be useful later. Yeah? The imports? Here. Okay, I can just zoom out if you want. This way? Okay, cool. And yeah, so we've created, I can just like swipe one time, just we created this. Okay, back to the code. Do you have any questions? Okay. Do we have sometimes to deploy, declare or not? 5 minutes? Okay. Okay, so we've just created one implementation inside one component, but we can have multiple implementations, and then we aggregate everything inside a smart contract. Tell me when you're ready. I just show you how it looks like without many explanations. So git checkout main. Oh, fuck. Can I just force it? Yeah. So this is the final project when you did all the steps, and this is, as you can see here, participant. There is the register to the board, save the board. Like this is what you just typed, without colors, because the language server is very slow. But at the end, we just like import components this way, and then we link our component storage and events to the contract storage and events this way. Again, it's very verbose, and I hope that it will be updated in a future version of the language. And then you add a constructor. It will be a method that will be called only on the deployment of your smart contract. So here on the constructor, you give a name, a board address, and the owner of the smart contract. So it will be another address, an account, which will be able to have some access right inside your smart contract. You can do whatever you want with the owner. Like you can just give no access right to your owner, but you can also like give your owner the possibility to upgrade the smart contract to another version, or like here we make sure that when we call still, it's only the owner which is allowed to call still. Assert only owner. Same for give. Or when we want to set losing strategies or receiving strategies, only the owner is able to do it. And yeah, I don't have enough time to go into the details. But that's how it looks like at the end. There is not much logic here. It's just like aggregating everything we did inside of our components. And then if we want to deploy that, or to declare it, we can just follow this, not here. Yep, here. So first, you will need scarb. So you probably already have it. Then you will need to create an account on Voyager. Here. Click here, sign in or sign up with a GitHub. I already have an account. Then you have all you can create API keys. It's a way for you to have access to the blockchain state through a classic HTTPS URL. I think I'm using this one so I can reveal the private key, which is just test. And this way you can have access to Sepolia, which is a testnet version of the blockchain. It's a version of Starknet in which nothing have value. So you can just make your test. You won't lose money on it. So you create an API key. I will just use this one that I've already created, but you can just click on create new if you want. And then add a snfoundry.toml file at the root of the repo. So I already have one. And then fill it like this. So you just copy paste that and replace API key with your actual API key. And then you can start interacting with the blockchain using this URL. So you install SNCast, doing that. I already have it, but yep. Then Foundry up. Beautiful. Then you have to make sure that you've installed the latest version of Universal Sierra compiler. It's supposed to be installed at the same time when you're running Foundry Hub, but sometimes not, so just run that also. This is into the README of the workshop, so if you want to try it home, you can just follow the same steps. As you can see, it's quite easy. And now we have SNCast, SN for Starknet, I guess. So what we will do now, we'll create an account. So SNCast account create name main. It will be the name of our account. I already have one, so main2. And yeah, that's it. Now I need to give funds to send some money into this account to be able to deploy it. It's on the testnet, so the money is not real money, so you can just go to a faucet. This one, yep. I just gave the link here, I guess, yeah, on this faucet. You can just put your address here. You ask for ETH. It's not a valid address. Sometimes you have to add some zeros here. Okay. Send request, and I will receive money, free money. It's a bit long. I can go into Voyager. on Sepolia. To see the money coming inside my account. Okay, we'll refresh later. It needs some time for the website to synchronize with the blockchain. Now I've apparently received some money. So I can try to deploy my account following this step, sncast, account deploy, name not main, but main2. Main2. Account deployed. You can have the hash of the transaction, so you can follow your transaction here. If I refresh, yeah. Yep, and I can look at ERC20 tokens. Okay, it doesn't know yet that I have some ETH. Never mind. So this is my account that I've just created, main2. And using this account, I can now interact with the blockchain. So with a command line, if you want to just interact with some protocols from website, you can just like use Argent and Bravos. It will be easier, no need to run commands and everything. But this way you can interact with the blockchain from your terminal. So that's cool. And yep, that was the last step. So now we can try to deploy, to declare first our smart contract. Ah, fuck. Sorry. So what we have, so we have the smart contract. We will compile it, create the bytecode, and we will send this bytecode onto the blockchain. We can do it this way. So sncast account main2. I forgot the T. Main2 and declare contract name. And it's player, the name of my contract. That's the name that you put here. So it's compiling, it's creating the bytecode, and then it will send this bytecode into the blockchain. And it will give me an identifier, so I can, okay, now it's not working, because it's already deployed. I will just make a small modification. So like if I, yeah, do it the other way. Don't try that at home, but yep. Yeah, you cannot send the same bytecode on the blockchain twice. There is no need to duplicate the same thing. Yeah, so now I have my my code on the blockchain, so here, and it has an identifier, which is a class hash, and I can deploy this class hash, like to create an instance of this class hash. And to do it, it will be sncast, again, account main2, and not declare, but deploy. Deploy and class hash. Tag. It's failing, yeah, because I need to give parameters to my player, I guess. So my player, okay, the constructor, it needs a name, a board address, and an owner. So contract, I'll just take a board address here. I've created one before. Okay, it will be fun. We can see on the blockchain that my my player will appear. So I put this board address. I join. There is nobody inside. Then I try to deploy. So constructor address, constructor arguments, I guess. I think it's arguments. Just take a look at the documentation to make sure. From the sncast deploying. Okay, constructor. It's constructor call data. So I need a name, a board address, and an owner. So the name, I need to send a number. So I will just convert a string to a number. I will be called the B. Tac. This is some hexadecimal, but inside this is the B. 0x the B. Then I give the board address, which is this one. You can follow the link if you want. It's workshop.child with a Q and .io. But you have access to this long. Okay, never mind. And an owner. So this will be the account which has access to your player, and I can just like give access to this. Access to my player to this account. And it's not working. No. And the location. Okay, it says that I cannot pass call data. Okay, what mistake did I do? So just give me a minute to fix that. Okay. Yeah, that's because I'm running this command into the wrong folder. So, tac. Ta-da, it's deployed, and if I refresh here, I can see the B. And yeah, you can also have access to the code of that website if you want to know how a website can interact with Starknet and read data on it, how you can like connect your wallet and then start sending transactions. Like what do you want to, it was what was planned for this workshop, but I made it too long. But that at the end, you can just fight, steal back, decide your strategy, decide if you want to steal, type the name of who do you want to steal, then click play. And yeah, that's easy. You can just run a command, and then you're joining a board. Yeah, as you can see, it needs some practice, but once you understand how everything is working, it's quite easy. It's just, yeah, you just have to get the mental model of Starknet, of the blockchain in general. But once you know how it works on Starknet, you know how it works on Ethereum, on Solana, and on every other blockchain, because it's always almost the same. Thank you for your attention, and I will update everything on the repository. So I will just put a message on the Discord of 42 Blockchain with a full README and all the steps if you want to do it at home. Yeah, I will keep you updated probably tonight or tomorrow because I need some sleep. Thank you.
Just 1 second to connect myself. Cool. So thank you, Charles, for the amazing session on smart contracts. I really like the whole front end, back end, and smart contracts, so it's really cool. I'll look into it. I also want to complete it, so that's really nice. Now, just to wrap up the whole Basecamp, make sure to scan the QR code. We'll share it in the Discord channel or the channels that we have together. But let's wrap up the 4-day session of Basecamp. To go next, if you want to work more on multiple workshops, we do have the counter workshop, which is basically a self-served workshop. Self-serve means something like this. So you have this workshop, and then it's step by step everything that you need to do. It takes you from the basics, and you'll able to deploy a smart contract as well. All the information is here. So counter workshop is in a similar fashion as the previous session that we had. And then we have the account abstraction. It's also self-served and teaches you how to build a account contract, and you can implement different type of features. Now, I think yesterday we wrapped up the Basecamp cohort number 9. This is an initiative from the foundation. It's online Basecamp. And what's interesting there is that there's some extra 2 sessions, mainly on front-end and Dojo, like building a game with Dojo. So if you're interested in those 2 sessions, those are kind of like the next step to learn about how to create a front-end with Starknet JS, and learn how to build a game with Dojo. And finally, we do have a hackathon guide. So this hackathon guide includes a bunch of things. You can see, like you have some short introduction, what Starknet is and proofs and everything. And then here on the right side, you have all the exercises, application frameworks, you have SDKs, faucets, so everything. And also you have some ideas and challenges that you can use. So this guide is kind of like a nice guide to use for hackathons and get inspired. What's next? I think in the previous, I think in the first session I mentioned about the Basecamp. So Basecamp is kind of like the next step of training, where you can use these skills that you learned throughout these sessions and join a team or even create a team and then work on a project. The nice thing about it is that we assign mentors to you, so you get help from us to get you kickstarted with the project that you want to develop. And it starts on June the 10th. The link is in the Basecamp, so make sure to register. Next up is the Stark Hack. So this is Starkware initiative in collaboration with Eat Global. It's a major hackathon happening. It's remote, so you can do it from anywhere you want. And you can compete for 75K in prizes. So if you have some nice ideas, you have a team formed, you can participate. Basecamp and Stark Hack, they're meant to help you. So Basecamp is meant to help you get prepared for the Stark Hack, so it's a nice go-through. Finally, we have the Starknet Hacker House. So this is going to happen right before ECC. Hacker House is kind of like 4 days in a hotel, and we have like a bunch of hackers together, and then there you can work on a project together and then build a proof of concept. And at the end, you have presentations to showcase what you've built, and potentially you could also have investors for those projects that you built. So it's a nice hands-on experience. You meet a lot of people, talented people. I would definitely recommend you to join the Hacker House. And finally, we have the Starknet CC. I should have exited Slack. Starknet CC, it's a day event. Everything is about Starknet. A lot of Starknet folks are going to be there, and I wouldn't miss it if it's possible. And if you want to check out more events happening, just give me one small second. Okay. If you want to check out other events that are happening, check out the Starknet events page. There are a bunch of them, so make sure to check out. There are meetups happening around the globe, hackathons, and so on. Now, congratulations to everybody. You made it. 4 days of hard coding sessions and theories, so just a round of applause to everybody. This is Spock, so let me step out from the view. Spock is Starknet Proof of Kudos. It's basically an NFT. It's going to be available for a limited time. It's available until 7th of June, so make sure to claim it. What I have to say is that you're at the right place at the right time. There's a lot of things to build, so get involved, get busy. There are a lot of opportunities. grants and programs. If you want, please reach out to us and we'll try to help as best as possible. I'm going to leave it for a couple of more seconds. You're going to have access to this presentation even after this session. So finally, here are my socials. So if you want to reach out to me, feel free to ping me on Twitter or Telegram. I'll be happy to talk to you, to help you and guide you, and anything that you might need. And that's it. First, I would like to thank the organizers, Luthing, and the rest of the team members for organizing such a great Basecamp and such a great spot. And yeah, I would like to thank you all for participating, and hopefully you guys have a nice session. Thank you.
Thanks a lot. Avec là? Okay, fine. Okay, great. So great to see you again after 4 days of hard coding. It's great to see you. So you have already seen this presentation, but let me just real fast do a very quick recap. First, thank you very much for all of you for the attendance. It's been 4 days, pretty long. Hope you liked it. If you want to join us, make sure to scan the QR code. So for the Telegram groups, there is also a link for all the events we're going to attend, we're going to have. So weather workshops, again, boot camps, meetups, all those kind of things. So yeah, feel free to scan it. I can already feel the vibes from the scan. So great to have you join. It was really great to have you all. Hope it's the first step of your Starknet journey. It was, again, amazing. Thanks a lot to the speakers, all the teams that came. So not to mention also Only Dust, Pragma, Carbonable, Starknet ID, and I think that Casa Labs as well. I would like also to warmly thank Robert from the foundation, the dev advocate. Would love to also to thank Charles, also a dev advocate from the Starkware, from Starkware. So thanks for the talks, for the courses. I would also like to warmly thank, and I would like everybody to clap to 42 Blockchain for hosting us, for having us. Thanks, Wilfried. Yeah, big up to him, and thanks a lot for having us in this beautiful building. So thanks a lot. Again, clap for him for the 42 Blockchain Association, and hope to see you again very soon in next events. So I'm gonna leave the mic to Wilfried, and feel free to scan also if you want to ping me to follow up. Thank you very much.
Thank you, everyone. It was a huge success. I hope you guys enjoyed and learned a lot. So we will do a lot of more events with Starknet France. So thank you, Eli, for helping us organize it. Thank you, Robert, for the course, and Charles too, and all the other people working on Starknet that have been presenting their project and their experience. I leave you just the link again, so you can join the Telegram groups of Starknet. I also put another event next week on Wednesday. If you want to open, it's a community night event when you can have drinks. It's at XRPL Commons offices. And so yeah, meet us there, and it's going to be a great evening. Thank you, everyone, and let's have some drinks later if you want, everyone. Thank you.
Just to know, who would be interested to do a workshop into multiple days to continue this? Okay. Okay, pretty much everyone. That's cool. Thank you.